How to find Q1, Q2, Q3 box plot? Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intudo for you has them all. It's like having a research dream team on demand.
Have you ever found yourself just staring at a page full of numbers, completely lost, with no idea what it's all trying to tell you? Yeah, we've all been there. Well, today, we're going to fix that. We're going to learn how to take all of that data chaos and turn it into a super clear, really compelling story using one simple, powerful tool, the box plot.
Okay, so take a look at these numbers. Just at a glance, what can you tell me? What's a typical value here? Are they all kind of bunched together, or are they spread all over the place? And what about that 92? Is that an important clue, or is it just some kind of fluke? Right now, it's just a jumble. It's just noise.
So here's the big question, right? How do we cut through all that noise? How can you, personally, just look at this and instantly get the story the data is trying to tell you, without spending, hours on some super complex calculations?
And the answer is the box plot. It is such an elegant, powerful chart that gives us this perfect visual summary of our data. It's what turns that chaos into clarity. And I promise, in the next few minutes, you'll know exactly how to read and even build one yourself.
So, here's our game plan. First, we'll look at the story a box plot tells. Then, we'll break down its anatomy piece by piece. After that, we'll build one from scratch. We'll also see how it acts like a detective for unusual data points. And finally, we'll unleash its true power, comparing different groups.
All right, let's start with the absolute basics. What exactly is this thing, and what's the story that it's designed to tell us? At its heart, a box plot, and sometimes you'll hear it called a box and whisker plot, is basically a visual cheat sheet for your data. It's built on just 5 key numbers, and with those 5 numbers, it shows you the whole shape of your data, where the center is, how spread out the values are, and if any of those values are, well, dramatically different from the rest.
And this is where the magic happens. With just one look, a single glance, you can grasp 4 absolutely crucial things. You can find the data's center, you can see how spread out it is, you can check if it's symmetrical or skewed to one side, and you can immediately spot any of those weird, unusual values that might need a closer look.
So, how in the world does one little chart tell us so much? Well, to see that, we've got to break it down. We need to look at its anatomy. The entire plot, the whole thing, is built on what we call the 5 numbers summary. It's simple, really. Once you sort your data from smallest to largest, these are just 5 key landmarks. The absolute smallest value, the first quartile, the median right in the middle, the third quartile, and the absolute biggest value. Everything starts right here.
Let's zoom in on the box itself, because this is the heart of your data. It represents the middle 50% of all your values. The left edge marks the first quartile, Q1, which is the 25th percentile. And the right edge marks the third quartile, Q3, the 75th percentile. So that means half of all your data points are living right inside this box.
Now, the width of that box has a special name, the interquartile range, or just IQR. It is a fantastic way to measure your data spread because it only looks at that middle 50%. That means it isn't fooled or distorted by any crazy high or low values. It shows you how consistent the core of your data really is.
Okay, so extending out from the box, you've got the whiskers. These lines reach out to the lowest and the highest data points that are still considered part of the main group. They really give you a sense of the full spread of your most typical data.
Okay, so we know all the parts. Now, how do they actually come together? It's time to get our hands a little dirty and build one of these from the ground up.
The process is actually surprisingly straightforward. Step 1, you always sort your data. From there, you find the exact middle. That's your median, which splits your data in half. Then you basically just do that again. You find the middle of each of those halves to get your quartiles. Once you have those core pieces, you're pretty much ready to draw.
So finding that median, also called Q2, is the first critical step. And it's really simple. If you have an odd number of data points, the median is the one sitting right in the middle. Easy. If you have an even number of data points, you just take the 2 middle numbers and find their average. That's it.
Now here's a little heads up. If you use different software, like Excel or something else, you might notice there are a couple of slightly different ways to calculate these quartiles. But listen, we are not going to get lost in the weeds here. The key takeaway is this. The methods might differ a tiny bit, but the core principle is the same, and the final story your box plot tells is almost always identical. So don't sweat the small stuff.
Okay, so we've built the box and the whiskers, and that represents our typical data. But what about the values that fall outside that typical range? Well, that's where a box plot turns into a powerful little detective for finding anomalies, or what we call outliers.
So what is an outlier? It's just a value that is significantly different from all the others. It's something that just doesn't quite fit in. Now, it could be a simple typo, or maybe an error in measurement. Or it could be a genuinely rare and important event. Either way, identifying them is absolutely crucial for an accurate analysis.
So how do we decide if a point is an outlier or not? Well, we don't just eyeball it and guess. There's a rule for this. The most common method is the 1.5 times IQR rule. We use that inner quartile range we calculated earlier to create these invisible fences on either side of our data.
And here are the formulas for those fences. We take 1.5 times the IQR and subtract that from Q1 to get our lower fence. Then we add 1.5 times the IQR to Q3 for the upper fence. Anything that falls outside these fences is flagged as an outlier. Think of it like putting a spotlight on any value that's behaving unusually.
So, we've done all this work, and the crucial question is, why? Why do all of this? Well, building one box plot is definitely useful, but their true superpower? That's revealed when you put them side by side.
This right here is where box plots really truly shine. By placing them next to each other on the same scale, you can compare the stories of completely different groups almost instantly. Forget staring at two long columns of numbers. This is visual storytelling at its best.
Just imagine comparing test scores for two different classes. First, just look at the median lines. Which class did better on average? Okay, now look at the boxes themselves. Is one box shorter than the other? That means its students were more consistent in their scores. Are the whiskers on one plot way longer? That means that group had a much wider range of scores. In literally seconds, you get this rich, detailed comparison. It's incredible.
So there we have it. We've gone from a confusing jumble of numbers to a clear, insightful story. We've learned how to find the center, how to measure the spread, how to spot the oddballs, and most importantly, how to compare different groups with just a single glance. The box plot is such an elegant tool for turning data into actual decisions. So, the only question left is, now that you know how to read them, what stories are you going to find?
And subscribe now for more amazing videos just like that. Thanks for watching.